Hello students, do you know each and everything that is occurring around us can be explained by the help of physics? Just like if we release the pen from here, it will fall down, or if we throw a ball in upward direction, it will eventually come down and we will catch it like Virat Kohli, right? So why these kind of things actually happen? These kind of things actually happen due to gravity. So today we are going to learn about gravity and gravitation. So what is the basic difference between gravity and gravitation? So there's a fundamental difference between gravity and gravitation. That is station. I am just joking around. So, what is gravity? Gravity is a huge amount of force that is exerted by a huge body, just like our planet Earth, on an object situated on the surface of that planet. Okay, that is gravity. That's why this plane falls down because our Mother Earth actually attracts it. Okay, exerts a huge amount of force on it. So what is gravitation? In this whole universe, any two object, just like me and this or this, or me and this cup, actually we attract each other. So that is called gravitation. So today we are gonna learn about gravitation at first. So today we are gonna learn about the universal law of gravitation. So what is universal law of gravitation? It was proposed by Sir Isaac Newton. So let us dig into it. Every object in this universe attracts every other object with a force that is proportional to the product of their masses and inversely proportional to the square of the distance between them. The force acts along the line joining the center of the two objects. So let me explain it with a diagram. Okay. So I will explain it with the help of a diagram. Let us consider we have an object A at A and also another object B at A. Okay. And the distance between their center is D. Okay. And the mass of A is M1, mass of B is M2. So A will exert a force F towards this direction on B, and B will also exert a force F in this direction. Okay, but why does it happen? It happens due to the third law of Newton. We all of us know actually. See, okay, all of us know the third law of Newton. What is the third law? Every action has its equal and opposite reaction. Every action has its equal and opposite reaction. So if a body attracts another body by 10 Newton force in this direction, the other body will also attract that body with 10 Newton force at this direction. Okay. So F is proportional to the multiplication of their masses. So if there is a M1, M2, F is also inversely proportional to the distance between their centers. Okay. So F varies 1 by D square. So if we combine these two, we can write by D square. Okay. So it will be G M1 M2 by D square. What is this G? It's a constant. It's not any just any constant. It's universal gravitational constant. So it's on our main focus right now. So what is the value of G? Its value is 6.67 into 10 to the power minus 11 Newton meter square per kg square. Kind of weird unit, right? I will explain it why its unit is like this. Okay. So the value of G is fixed in this whole universe. The value of capital G at our Earth, also at the Venus, will be same. All over in our world, all over in our universe, it will be same. Okay. So we need to remember this value. Okay. Now let us derive the unit of g. So we know that F is equals to g m1 m2 by d square. So from it we can calculate the value of g. It will be f into d square by m1 into m2. So we will simply put the unit of f, d and m1 and m2 in it. So n Newton, n is the unit of force, d square means meter square, and kg into kg will be m1 m2. So we're taking all units in SI, Newton meter square per kg square. So we can write it as per kg square. Okay. So we have learned about the universal gravitational constant. But there must be a question arising in your mind that, sir, if you have said that each and every object in this universe actually attracts each other, okay, like if I am attracting this cup or this cup is attracting me, then why it's not sticking with me like this? If you and batchmate of yours or a schoolmate of yours, classmate of yours actually attract each other, then why you aren't you guys sticking with each other, right? So let me explain it. It's a very amazing type of concept. Let me explain it with the help of numericals. That let us consider there's a boy of mass 50 kgs and there's another boy of mass 40 kgs and the distance between their center is kind of, let us consider 2 meters. Okay. So why aren't they? They're actually attracting each other, but why aren't they sticking with each other? Why? Because we know that if is their attraction force between them will be F equals to m1 m2 by d square. We know that. So what is the value of g? 6.67 into 10 to the power minus 11. And m1 will be 50 and this will be 40 by d square means 2 square. Okay. So it will be 4. 4. Okay. So if you calculate this, we will get a value like 3 into 10 to the power minus 10 Newton. Newton. Okay. So here we can see the term 10 to the power minus 10. Okay. 10 to the power minus 10. What does it mean? It means 3 by 0, double 0, 0, 0, 0. So here we can see the value of f is very, very, very much small, right? Very, very, very small. It's very small. So the attraction force between those two boys is very small, very small. So they can feel it, right? They can feel it. That's why they are not sticking with each other. But when it comes to play, when in case of two planets, right? In case of moon and our Earth, we actually know that moon actually revolves around our Earth. Why it does that? Why it does that? Because of huge amount of gravitational force with attraction force between them. Okay, so we can say that unless m1 and m2 are very huge mass, the gravitational attraction force between them will not be great, right? Now we will see that how f actually changes with changing d. Okay, so if there's two objects and the distance between the center is d. If we change the distance, okay, if we change the distance, I am sure that the gravitational attraction force between them will also change. There you will face some kind of questions like that. If we halve the distance between two objects, if we double the distance between the objects, if we triple the distance between the objects, how the gravitational attraction force between them will change. Okay, so I will tell you a trick. Okay, you don't need to calculate it. Hi, it's quite easy to calculate, but you don't need to calculate it. Okay, it will save your time. Just like if we double the distance, okay, then what will happen? You just need to inverse it and then square it. Double means two times, so inverse it and square it. So the new gravitational attraction force will be 1/4 of the previous one. Okay, if we triple it, then inverse it and square it of the previous f. New f will be 1/9 of the previous f. If we half, so 1 by half square means 2 square means 4. So of F will be the new gravitational attraction force. Okay. It will be very useful in the numericals when we will try to solve it. Okay.